Hello guys, welcome to another episode of Data Structures with me, George Wolfers. Um, Today, like I said, I think I said this in the last video of the stack implementation, that I was going to be talking about stacks. Okay, so first thing is first, let's create a new project. And no, not C sharp. Want Visual Studio, empty project, and we'll call it Data Structures Queues. Queue. Right. We'll right click here and set as startup. And we're going to add another item, a CPP file. We're going to call it just main CPP. And let's create another file, a header file this time, and we're just going to call it Q. Let's say header file. Okay. Oh, I would actually not defined Q define diff. I create a class called Q. All right, so what is a queue? Yeah, queue is it is a FIFO structure or a first in and first out structure. This means that it's the reverse of a stack. If you remember, the stack was a LIFO structure, which it is a last in, first out. So the last item that you inserted into your stack, that is the first one that's going to come out. In this one, it is the first one that you place in. It is going to be the first one that you're going to take out of this structure. You can think of this structure kind of like a line of people. Let's say you got a line, oh, not that. Okay, let's say you got a line of people. These are your people. And here we have a register where you buy stuff, right? It can be, grocery or place or movie theater, just a line of people. And this, you can consider this to be our pointer, our our head pointer, like we've had in our singly linked lists in our stacks. Okay, so the first guy here, it's a first serve. Um, you know, you get there first, you're served first. That's pretty much what a stack is. So when this guy gets here, he's gonna buy whatever he wants to buy, and then he's gonna leave. Okay, and then the next guy in line is gonna do the same. He's gonna buy it, and then he leaves as well. And then the next guy is gonna come to the register, pay for stuff, and he's gonna leave, and so on and so forth until there is no more, no more people inside of this line that they're trying to buy stuff from or whatever. So that is pretty much what a queue is. So let's see. A queue can be considered to be a line at a grocery place or at the movie theater or anywhere where there is a line. Um, it is a first come, first served idea, I guess. Um, so whatever, let's say you were holding tasks, like let's say we're talking about a printing machine. Um, let's say you're at school or something, and you have every computer at school is connected to a server. And whenever you want to print something, let's say you got 5 people that want to print, there's something called a print queue, and it pretty much works the same way as this. And it queues up the tasks for print services. That way, there's, not every computer is sending directly information to the printer at the same time. You have to separate it, or you can lose data, or something, I don't know, something bad can happen like that. Okay, so we are going to be using nodes as well. So let's call it our queue node, and we are going to have, like always, a value that we want to store and a pointer to our next queue item, right? This is our constructor. Let me just public real quick right here. Our public section and a private section, and here we want to have a a head pointer like in every other place we've done so far. And you don't really need, since we are only taking stuff out of the front, or the first item that you enter, um, we don't really need a tail for this. It depends on where your first item is located at. So for this one, we are just going to stick it in here, and we'll just push the we'll keep the first item in the head and we'll push the rest out into the other places. Okay. We want to set this guy to 0. And a queue has two functions that make it a queue, just like the stack has a pop and a push. The queue has the same thing, except that in a queue, it's called enqueue, and here is where you enter, you push stuff into your queue, and then we have a dequeue, which just let's keep these like this, and this one pushes items into the queue, and this one just removes items from the queue. Okay, and this one is just gonna be initializer. Or constructor. So that is pretty much all we need to make a queue. Now the first thing we are going to do is put stuff in it. So how do we want to do this? Well, since I said that we want the first, we want to put stuff only in, no, we want to keep the first item in the head, and then we want to, push everything back. So let's just do a quick check that if this guy is empty, then we are going to add stuff here. Well, let's make it out here so we don't have to rewrite that one. And we want to set the value equal to new value like before, and the next, it's just going to be 0. Then, well, we could actually also put this up here, since it's going to be the same for everything that we input. So if our head is empty, then we want to set the new node to be the head. If it's not empty, then we just want to say, we want to loop int I, oh, no. For int qnode, let's call this iterator or whatever, and we're gonna start at the head. And we're gonna loop as long as iter does not equal null. And then we're gonna increase our iterator. So we don't have to do anything here. And when it returns from this loop, yeah, making stuff more complicated. Should be. You know what? Since we are going to be adding stuff at the end of the list every time, might as well give ourselves a tail. So we, so we're not doing weird stuff like this. So all we have to do now is just say tail equals blah 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 new node and new node. No. Next, because we don't want to. We want to set the new node at the end of the list. So we gotta call in our next pointer and set it to the new node. We don't want to do what I was just about to do, which is this, because then we will just be overriding the tail. Okay, once that the last one is set, we want to do this. Yes. Either that or tail next. Either one will set the tail to the end of the queue. And that is everything for this. Okay? So that is that is everything that we would like to do here. Inserting. The next thing we want to do is DQ. Some DQs let you extract like the peak in the stack function. If you guys remember, where's our stack? Right here. Have our stack right there. So if we go into the peak, it just returns the data right here. So what I am going to do is just do that same thing, but right here. So since we have integers, right here, our value is an integer. We just want to return whatever value we get. But first, we want to actually, if we do this, you know what, we'll just make a peak function, because if we do this, we are not going to be able to delete it. We can unlink it, but it'll still be in our memory. Okay. So I'm going to do this, and here we're just going to make a temporary node. We can just say deleted node. Damn it. set it to 0. No, I probably didn't do that. Oh, right there, new. Never mind. Okay, so here we want to first we want to link. No, first we want to check, make sure we have something here. If we do have something in our head, that means we do have data. And then we also want to check if our head next, if we have something in our next. And if we do, then we're just gonna say head equals, well, before we do that, don't get ahead of yourselves. We gotta set the deleted node that we want to delete to the head. Okay, and then we're gonna set the head to the next pointer. Then we want to delete this node. And that's it. Okay. Choose to return or not. Doesn't matter. Now here, I am going to do a peek just like in the stack. And it's just going to return the head value. And don't make sure you make sure that we're always checking anytime we want to return something or do something with the pointers, we gotta make sure that they are not pointing to any memory that is not accessible. Otherwise, you're gonna crash. And what this function does is here we're just returning the current value of the queue. And that's it. That's all it takes to create a queue, a simple queue. Now, I'm going to go back here, and we can actually close these. Okay. So let's copy this whole thing. Paste it right there. This is just the GNU license that tells you that you can do whatever the hell you want with this code that I am uploading every time. All right, so here we're gonna make sure that our queue works, and we need IStream to be able to print out stuff, and we're gonna say using namespace std. Then we're gonna create a queue, and we're gonna call it, I don't know, queue or something. We're gonna be creating it on the stack, so we don't have to free anything. We will, however, have to implement a Destructor so we can clear all the data that we have in here. And we already have, if you remember, we already have a way of doing that. It is called our clear function, just right here. So we can just copy this whole mumbo jumbo from the stack. Just paste it in there. Sure to place everything that is not part of this header file. No size here. This is a key node. Next. It's not a function. There you go. Boom. Okay, so we're just going to do a little for loop. We'll start at 0, and we are going to do until I is less than 10, which is 9, and we are going to increase that here, and then we're going to say q dot onQ, and we're going to do I, okay, and then we're going to print it with the same stuff, but instead of saying onQ, we want to say peak, and we want to see out, let's say Q, actually we cannot do the whole thing because damn it. Actually we can, yes. We can just do peak followed by a DQ. So first we are going to get the item to print, and here we're just going to be removing the item from the queue. And we're just going to say cout queue item. Let's say here, just end line, and we're going to do that. We're going to call our get car function. Is it get car? I think so. And now we're going to run it. See what happens. So we should see everything sequentially. Yep, we do. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That is very good. And everything works. So, yeah, that's pretty much how a queue works. It is just a data structure that you can um, push stuff in this structure in sequential order, pretty much. Whatever you put in first, it's always going to come out first. I've used this before in artificial intelligence, where you have to, the A-star algorithm, to find the shortest path, we use the queue in order, to store the actual path, the shortest path, into this queue, and then as we returned it or removed it from the queue, our guy traversed in order from the closest one all the way to the farthest one, the destination. And yeah, he walks. Pretty cool. And if you do a queue, then he would start at the end. I mean, a stack, if he would start at the end and make his way over here to the start. So yeah, it's pretty interesting how these things work. You can do a lot of stuff with these. Like let's say you have I don't know, maybe a chat server or something. Um, and let's say you have a certain number of people that can join your chat. You can, and if more than those people, more than that amount of people try to join it, you can add them to a queue and tell them, oh, you gotta wait, you're like the first one in the queue or something. You have about 7 seconds till the next person logs out so you can join in. Some games do that. Like when the worlds get too big to store, any other people or whatever. They put you in a queue, and then you gotta wait until someone logs out or something. So yeah, that's a queue. If you guys have any questions, let me know. I know I went through pretty fast on this thing. Um, if you guys want me to create another demo, I will. Um, right now I can't really think of any. Um, so yeah, sorry. If you guys like my tutorials, don't forget to check them out. If you guys have comments, concerns, or whatever, message me. You can, for those of you that want to follow along and or get other tutorials that I've made, I have them right here on my GitHub account, and it's called Wolfer's Toolbox. So right now I'm going to upload the queue as soon as I am done recording. Yeah, that's about it. Thank you and have a great day.